All right, 8.3 is solving rational equations. Then we'll do a couple inequalities on the back side. So it's kind of similar to simplifying expressions. As a matter of fact, I think it's a little bit easier. But the big thing is, here in this first paragraph, rational equations contain one or more rational expressions. They have fractions in there, with x's in the denominator. To solve these equations, we got to start by multiplying each term by the least common denominator. So that's kind of our go-to method here. And hopefully, if we do it right, that step will eliminate all the denominators. So after step 1, we should not have any denominators left to deal with, which is nice. So here we go. We'll go to the very first one. Number 1. I'm going to rewrite this as x over 1 plus 8 over x equals 6 over 1. It's just a little easier to kind of see when we're first learning like what the LCD is. So when I look at the bottom numbers, 1 and x, the LCD there is just 1x. So I'm going to multiply everybody by x. I'm going to multiply u by x, and multiply u by x, multiply u by x. And that'll give me x squared plus, well, 8x divided by x, those x's cancel. I just get an 8. And then 6x divided by 1 is 6x. Set it equal to 0. Something we learned earlier in the course. Always try to factor it. That's usually the easiest way to solve these. And I think the combination is going to be -4, -2. 0 product property. So x equals 4 and x equals 2. Then I want to double check and just make sure, is it okay to put those numbers in there? Do I make the bottom equal 0? I don't, so we're good. X equals 4, x equals 2. All right, next one over here, I have 10 over 3 equals 4 over x. You might want to leave yourself some room just because you're going to be multiplying by something. LCD for this one, 3x and 1, so the LCD is 3x. So I'm going to multiply by 3x, multiply by 3x, multiply by 3x. And the 3's cancel. I get 10x. The x's cancel. I get 12. And this just ends up being 6x. Do my algebra. And I get x equals 3. Then I ask myself, is that okay? Put it in. Yep, 4 over 3 is good. So the answer is 3. Go to the next one here. This one, I have a 2 and an x minus 7. So my LCD is just going to be 2 times x minus 7. I'm not going to multiply it out. I'm going to leave it separate because things cancel rather nicely. So a couple different ways. If I wanted to write this all out, I could write the 2 times x minus 7 by all the pieces. I'm just going to kind of do this a little bit differently. I'm just going to kind of put a big parenthesis around this whole thing, or a bracket. And I'm going to multiply everybody by 2 times x minus 7. And, you know, when I multiply it times this first term, this x minus 7 and this x minus 7 goes away. So I really just have 2 times the top expression. So that's going to give me 4x minus 36 plus, well, now in the next expression, I'm going to have this 2 down here is going to cancel with that 2. So it's basically going to be x times this piece. So that's going to be x squared minus 7x. X squared minus 7x. And then when I do the 5 times that piece over there, when I do this chunk times that, the x minus 7's cancel. And I just have 2 times 5. 2 times 5 is 10. So again, no denominators. They're all gone. Kind of works easier if you're in class and you can see my hand and I kind of cover it up with my hand, but we'll do our best. X squared plus 4x minus 7x, that's minus 3x. I got to move the 10 over. So move the 10 over. I don't know why I got 4x minus 36. That should have been 4x minus 18. That 2 times that 9 is 18. So minus 3x minus 28. So I had to minus 10 from both sides. Looks like 4 and 7. And the 4's got to be positive. The 7's got to be negative. So I get my two answers. But when I go to the top, I cannot put 7 in there because 7 minus 7 is 0. So you're not an answer. You are what's called an extraneous solution, meaning that, yeah, I did the math, I found a solution, but when I put it back in, it doesn't work because the bottom is undefined, it's 0. So correct answer is just x equals negative 4. Well, number 4, both denominators are x minus 3. So if I have something over x minus 3 equals something else over x minus 3, I basically can just set those two equal to each other, which gives me an answer of x equals 3. But when I go back to the problem, there's an issue. You know, when I try to put that 3 in here, 3 minus 3 is 0. So you're an extraneous solution. And I have no other number. So when that happens, we say that this equation has no solution. Could also use the empty set symbol, the null set, if you'd like. So now you can also solve rational inequalities using algebra. Kind of have to consider two cases. What if the LCD is positive and the other is negative? I'm going to actually do this a little bit different. So just kind of watch what I'm going to do here. So the first thing, I'm going to kind of do step 1, which is I need to find the excluded value. I'm going to find the number that I know can't work. So what can't work here is x minus 2 equals 0 is going to cause a problem for me. So when I solve that, I know that x cannot equal 2. You know, I didn't really have to do algebra. I could kind of just look at this over here. So what I'm going to do is down here, I'm going to put kind of a number line. And I'm going to put negative, or I'm going to put 2 on there. And I'm going to say, hey, I know that x cannot equal 2. So I'm going to put an open circle. Right now I know x can't equal 2. Well, then I'm just going to solve this thing as is. And we started this in class, and I'm going to do it a little bit differently than I did it in class. I think this will work easier. So I'm going to multiply both sides by x minus 2. So times this side by x minus 2, times this side by x minus 2. Goes away. And I get 6 is greater than or equal to negative 4x plus 8. And I'm just actually going to just pretend that it's equal. I'm not even going to worry about the greater than, less than symbol. I'm just going to be like, you know what, let's just set it equal. And I solve this, and I get negative 4x, negative 2, divide, divide, and I get x equals 1/2. So I'm going to go here on the chart, and I'm going to put in a 1/2. And x can equal 1/2. So what I did, I'm going to just put this step in over here. So we found the excluded value, all right. Then we just solved with an equal sign in there. And now what I'm going to do is I'm going to test each region. Okay, I've kind of got my two boundaries here. I've got when is it equal and what can it not be. And if I kind of put in some dotted lines here, if I kind of come in and I'm like, well, you know, I'm looking at this region. There's 3 regions here. And I'm going to test each one. I'm going to pick a number. I'm going to stick it in and I'm going to test it. So if I pick a number over here in this region, so on a number line, let's just try 0. Let's stick 0 in there. So I'm going to test 0 and go back to my original equation. Let's just stick 0 in here and see what happens. Well, that would be 6 over negative 2 is greater than or equal to negative 4. Well, that's negative 3 greater than or equal to negative 4. Is that true or not? Well, negative 3 is greater than negative 4, so this region is a yes. Well, now we need to test a number between 1/2 and 2. Let's try 1. So let's go 6 over 1 minus 2 and see if this is a true statement. Well, 6 divided by negative 1, that's negative 6. Is negative 6 greater than negative 4? No. So that region does not work. And then finally, I got to pick a number bigger than 2. Let's go 3. So 6 over 3 minus 2. Well, that's 6 over 1. Is that greater than or equal to negative 4? That's a yes. So I have a solution region here. And basically, this kind of goes back to algebra, so you may have to kind of remember this. But if this region works, so that is x is less than or equal to, because I got a closed circle, 1/2, or this region, which is x is greater than, it's not equal because that was an open circle, 2. So these are the areas that make that thing true up there, and the spot that doesn't work is between 1/2 and 2. I think this is a little bit easier than what we did in class or what we started to do going really hardcore algebra. I think this makes a little more sense. All right, so let's go through our steps again. This time we'll go a little bit faster. So get our number line down here. We're going to get 3 regions. So first region is, let's figure out, when is x plus 3 equal to 0? Well, x equals negative 3, so we know x cannot be negative 3. If I assume 0 is in the middle, I'll just kind of put negative 3 over here. Maybe use a little color. So x can't be negative 3. Now we just solve it as is. 9 over x plus 3 equals 6. Maybe I'll do it over here because I need some room to test. Well, if I just multiply by x plus 3, I get that. And minus the 18, get that. And looks like I get a little fraction action, which is negative 1.5. So negative 3/2, aka negative 1.5. So now I have my 3 zones, 3 regions, and this one over here cannot be equal, because if you go back and you look at our original problem, that was a less than. So this is open as well. And now let's start testing. So now we got to pick some numbers. So I don't know, let's try negative 4. So 9 over negative 4 plus 3, is that smaller than 6? Well, 9 over negative 1, that's negative 9, smaller than 6, yes. Let's try something between negative 3 and negative 1.5. How about negative 2? It's pretty friendly. So 9 over negative 2 plus 3 is 9 less than 6. This is no. And then we're going to try one more. We'll try 0 because that's easy to plug in. Is 9 over 3 less than 6? Is 3 less than 6? Yes. So it looks like I'm going to have x can be less than negative 3, or x can be greater than negative 3/2. Now, both of those examples were yes, no, yeses. That's not always going to happen. So I'm sure when we do a homework problem or two, we'll see a little different setup than what we had there.